Hello students, welcome to Wallah English channel. In this video or in this session, we will be understanding various operations which are called as closure properties that we are going to apply for the context-free languages as well as deterministic context-free languages. And here the domains are either DCFLs or domains. Domains are two types here. One domain has all DCFLs, other domain has all CFLs. Now when the domain is DCFLs, what are the closure properties are closed and what are the closure properties are not closed? Okay, so here mostly we don't look at the proofs, but we look at what are the operations which are closed and not closed. Okay, let me discuss one by one what are the domains that we are going to look at, some closure properties that we are going to look at for CFLs and DCFLs, some important points from these closure properties. Then I'll give you some practice questions to do. Okay, let's start with the closure properties. Mainly, what is a closure property? If any closure properties, that is called as operation basically. What we do, we need a domain. We need what? Domain. This is, let's say, D. And here there are so many languages, maybe DCFLs or maybe CFLs or maybe regulars, but here CFLs and DCFLs we are going to discuss. And we need some operations. Like, let's say union you are applying. Now this, let's say this is L1 and this is L2. And these two languages you take from this domain, not these two, every two languages you take and apply the union. If the result is always in this domain, then we say that union is closed for this domain. So this is what we talk about, closed and not closed. So closed and not closed, these are the two words that we discuss in closure properties. And we already learned these two definitions in closure properties of regular languages. There we already learned about these two words. Now we are going to look at what are the closure properties which are closed for DCFLs and not closed for DCFLs. Then we'll look for the CFLs. Okay, let's start with first closure properties for DCFLs. Okay, so I'm going to write some important operations here. Union, and you are taking these languages from domain which has DCFLs. Intersection, then complement, very important operations. Concatenation, then reversal. Okay, Kleene closure, positive closure, subset of L, nine. Of course, difference you may write, but I did not, but you can write if you want it. 10, very important operation which is prefix. But also remember the suffix, substring, they are not going to be much important, but they are not closed. Suffix and substring are not closed here. So let's talk about this 12 operations. Which properties are closed for DCFLs, which are not closed for DCFLs? If you look at the union is not closed, so I'm putting the cross mark to understand it is not closed, and tick mark is closed. Here the union is not closed, intersection not closed, but complement is closed, and concatenation no, reversal no, not closed. See, almost all are not closed, see that, but prefix is closed and suffix, substring, all are not closed. So very easy and very simple to remember. These prefix and complement operations are only closed for DCFLs from this closure properties list. Okay, in the exam you can just remember that, complement prefix are closed for deterministic context free languages. Now look at why this complement is closed. If the complement is closed, that means there should be an algorithm or proof to say that is closed. The reason is, for any language, any DCFL, you can always design a DPDA. When you design a DPDA, right, so if really you make a deterministic oppositional automata, just do one thing, interchange final non-finals, then you will get the DPDA that accepts L complement. But before interchanging final non-final, you must guarantee that for every combination of the input and top of the stack, you must have exactly one transition. If you miss any transition, then interchanging final non-final may not work. So you make exactly what DFA looks like. If you design a DFA, interchanging final non-final and DFA, you will get the another DFA that accepts a complement of a regular. The same way here you make a DPDA which looks like the DFA way. In the DFA, we know for every string exactly one path you will be having. Here also you can make a DPDA for every string you will be having exactly one path. If you can make that DPDA, then you can make interchange final non-final, you can get a DPDA that accepts complement of DCFL. That is the reason you have a proof. Even prefix also, that's similar to DFA proof, that a prefix operation also you can modify the DPDA to get the new DPDA which accepts prefix of a DCFL. And except this two, remaining all are not closed. The reason is, like, there are DCFLs, their union you will not get a DCFL. We don't look at for getting a DCFL because you need a counter example to get not closed definition. So there are examples of DCFLs, their union you get a not DCFL. That is the reason union is not closed. Okay, just look at the union, how it works. Okay, union. So DCFL, union, DCFL, the result you may get, of course, you get may or may not be DCFL. So it is either DCFL or not DCFL. May or may not be DCFL. If it is always DCFL, you can say that it is closed, but may or may not be DCFL. So you have examples, infinite examples for not getting not DCFL. So here I'm just taking one example to help you. If I take a power n, b power n, this is a one language, right? This is L1, and L2 I'm taking a power n, b power 2n. And when you do the union, L1 union L2, you get something different, like a power I, b power j, such that I is equal to j, or that j is equal to 2i. Now this is not a DCFL. This example is enough. Why it is not closed. This is a DCFL. It is a DCFL, but you get here not a DCFL. In fact, it is a context-free language. Here may or may not be DCFL, but you get always a CFL. Always context-free language you get. Because in context-free language, for the union we have a proof. The CFL union CFL, you get always CFL. Okay, so there this result depends. Fine, this is the best example to remember. DCFL union DCFL, you may get a DCFL, you may not. Do you want example for DCFL? Take the same example, a power n, b power n, the same one you take here, then union you will definitely see the DCFL. Okay, sometimes you get a DCFL, sometimes you get not DCFL. That's why union is not closed for DCFLs. Okay, the same way intersection also there. Same way intersection. If you do DCFL intersection DCFL, you may or may not get a DCFL. May or may not be DCFL. So you want to see example here. See here, a star b power n c power n. Very simple example. This is what? DCFL. It is a DCFL. How? Because you can skip the A's, you can push the B's, you can pop the B's for the C's. So you can deterministically design a push down automata. And when I do a power k, b star and c power k, this is also DCFL. But when you do the intersection, right? If you want to do the intersection, L1 intersection L2, what happens? Here A and C equal, here B and C equal. So if you want common thing, right, the C is connected with B and A. So all the three should be equal, A power n, B power n, C power n. And we know this is not a DCFL. In fact, it is not a CFL also. Here the answer you can write may or may not be CFL, because you got an example which is not a CFL2. This is not a CFL2. Okay, so DCFL intersection DCFL may or may not be DCFL, but you get always context sensitive language. No guarantee of the CFL, right? But you can guarantee always context sensitive language after doing the intersection of two DCFLs, right? Maybe regular, may not be regular, maybe finite, may not be finite, but you always get a context sensitive language. And the best, this is the best one. And when you go for the complement, remember there are so many complement examples for DCFLs. The result is always DCFL. So if you want to see example like A power n, B power n, this is, let's say, L1, and its complement, that's sigma star minus, that's A power n, B power n, complement is nothing but, that is sigma star, A plus B whole star minus A power n, B power n. So this one you can design the same DPDA but interchange final, non-final. This is also going to be a DCFL. Just I'm saying this example only. Okay, both are DCFL. This is a DCFL, even complement also DCFL. Second, L2. If you take anything like W as W power R, even you can take regular also, because regular is also DCFL. We know it's a DCFL, right? It's a DCFL. When you do the complement, you will again get a DCFL. Will again get a DCFL. So take any DCFL, whether it is regular or not regular. Even I can take regular also. If you really want, you can take regular also. A star, B star. It is also DCFL. It is also DCFL. It is regular means DCFL. L complement, this L3 complement also DCFL. Was regular too, but here complement is regular, here complements are not regular. So it doesn't matter regular or not regular, but always DCFL. So DCFL complement is always DCFL. So this is about DCFL closure properties. DCFL closure properties. Now we look into the CFL closure properties. What are the closure properties, or what are the operations closed for CFLs, not closed for CFLs? Okay, I'm not going to discuss every operation, but some important operations I'm going to discuss here. The first one, same like union. These closure properties we are going to apply for context free languages. Remember, I'm changing the domain now. This one, L1 union L2 means union for CFLs. Intersection for context free languages. Complement for the context free languages. And difference, concatenation, reversal, clinic closure of CFL, positive closure of CFL, and then subset of CFL, prefix of CFL, suffix of a CFL, and then substring of CFL. Substring of CFL. And among this 12 operations, most of them are closed. So 1 is closed, 2 is closed. Oh, sorry, 2 is not closed. Intersection, the same example you can take which you have taken in DCFLs, right? DCFL, intersection DCFL, you got a CSL. The same example you take, every DCFL is a CFL, right? CFL, intersection CFL, you get also CSL all the time. But sometimes it may be CFL, may not be CFL. Okay, so this is not closed. And complement is also not closed. Difference, No. Concatenation, yes. Reversal, yes. 𝐂𝐚𝐿 closure, 𝐂𝐚𝐿 plus. Subset, no. Prefix, suffix, substring. So here the very important list which is not closed. Intersection, complement, difference, subset are not closed. And remaining all like union is closed. And what else? Concatenation, reversal, 𝐂𝐚𝐿 closure, 𝐂𝐚𝐿 plus, prefix, suffix, substring, many are closed. Okay, so if you look at the union, why this union is closed for CFLs? Because you can use the context free grammar or you can use the PDA to prove. You can design one PDA, you can design another PDA, you can just take a new PDA and that PDA goes on epsilon to this one or on epsilon to this one. That means you have done the union of two CFLs. Or you can take a context free grammar proof. You can write a one context free grammar, you can write another context free grammar. Now you write a new context free grammar just by taking the start symbol of this one or start symbol of this one. So you make a new grammar with the help of these two grammars. It's possible to make a new grammar. So union of two CFLs is CFL, right? Intersection of two CFLs is need not be CFL. Don't say not CFL. May or may not be CFL. Okay. Complement of CFL may or may not be CFL. So write these three important points that you may require. Okay, first one, CFL union CFL. The result is always CFL. Second, but when you do CFL, intersection CFL is always context sensitive language, but may or may not be CFL. That to remember, may or may not be CFL. Third, CFL complement. This one is always CSL, but may or may not be CFL. Don't say not CFL, that is a wrong statement. That depends on example, okay? But it is also always context sensitive language. So context free language complement is always a context sensitive language. Look at some important points in the closure properties. Okay, many questions are there to understand, but some of them I'm just writing here. The first one, suppose somebody given you CFL union DCFL. What will be the best answer that you can give? Okay, I'm not asking possibility, I'm asking always what is the right answer. DCFL, regular, CFL, not CFL, what is the best answer that you can give? Okay. Second, if you do CFL intersection DCFL, what is the best answer that you can provide? Okay. DCFL reversal, what is the best answer? CFL reversal. You can take the help of closure properties because I am asking in general, so closure properties will give you some idea. First one, oh, this one you can't take the closure properties help, but you can try. See, CFL union, if you assume this is a CFL, right, it's always CFL, guaranteed, because CFL union CFL is always CFL. Oh, that makes you can always prove you have a PDF for after union, or you can prove that you have a context free grammar after doing the union. You can write a context free grammar, you can write a context free grammar, union of two context free grammars, you can get another context free grammar. Okay, now CFL intersection DCFL. Now look at, even though you assume this is a CFL, CFL intersection CFL, no guarantee of CFL. So this one is a context sensitive language, context sensitive language. Okay, reversal of a DCFL may or may not be DCFL. This is a very important point, may or may not be DCFL, but always CFL. CFL reversal is CFL, but DCFL reversal may or may not be DCFL. But you can answer here, you get always context free language after doing reversal of DCFL. Okay, after doing reversal of DCFL. So this is how in the exam they may ask what happens. L1 is the CFL, L2 is the DCFL, and what happens L1 union L2. So is it CFL or CSL or whatever it is, may or may not be. Let's look at some examples to understand more. Different examples like L1 is equal to A B power n C power n. Okay, and L2 is A power k B power k and C. And the question might be like L1 intersection L2, What is it? So can you try this? L1 intersection L2, what is it? Now, many people write some different way, like A, B star, C star. So don't do any such things. Okay, first understand what is the very important restriction here. Here A is the important restriction. So except 1A you can't write more, and here 1C is the restriction. So always 1C is there, here always 1A is there. When you do the intersection, definitely 1A, 1C should be there. And what is the in between? Is it B power K? What? You can do that. If you write B power K, right, then A power K you should write. So you can't write B power K. And if you write B power N, then C should be power N. So but only 1C is there. When 1C is there, it demands 1B. When 1A is there, it demands 1B. So only one string which matches, that is A, B, C. There's a one string which is a common to both. Nobody else is a common to both. Only one string, that is A, B, C. Right? The language which has only one string, that is intersection of these two languages. Okay? Let's do another one. The second. L1 is equal to A star B power N C power N. Now L2 is A power K B power K C star. Okay, C, we'll just write 1C. Let's see what can we do. If I write C star, you may answer it very quickly, I guess. Okay, 1C. Then what happens now? Let's look at what is the intersection. L1 intersection L2 we want to know. What is it? See here, what is must? 1C. When you put 1C here, this makes 1B. So you got the answer. 1C is definite because that can only be common. And when you put a 1C, then 1B. When you put a 1B, then it demands 1A. So this is only one string which can match both. If you try right, you will not get any other. Only the one thing which is possible in both of them, that is A, B, C. Here, maybe C square possible, B square possible, but here impossible. Okay, so you should get C power 1. When you get a C power 1, B power 1. When you get a B power 1, that's possible A power 1. So interchangingly you need to understand there's only one string common to both. Anyhow, these two are not same examples, but the answer is same for both. Okay, so very important concept in context-free languages, or deterministic context-free languages. Okay. Okay, let me ask some of the closure properties here. What we have, that subset, and yeah, subset of DCFL is what? Will you guarantee every subset of DCFL? Can you guarantee DCFL? But see here, finite subset, this is a different. Finite subset of DCFL, what will you get the answer? 3. Subset of finite language is dash. Even subset of regular language. The subset operation is very, very important. And what is that subset? First one, subset of a DCFL. We know subset operation is not closed for regulars, not closed for DCFLs, not closed for CFLs. So this result, anything is possible. May or may not be DCFL. May or may not be DCFL. And finite subset of not only DCFL, you take any language in the world. You take a CFL, you take a CSL, doesn't matter. Finite subset, when you take, the result will become finite set. And in the exam, if we don't see finite set, You can answer regular, you can answer DCFL, you can answer CFL, CSL, because finite subset of any language in the world is going to be finite. Then this you can call as per the given options that you have. Okay. Subset of a finite language. The input is finite language. When you pull the subset, you always get a finite again. So these two are very important. Finite subset of anybody is a finite. Subset of finite is always finite. Okay. But subset of a regular, you may get even not regular and you may get a regular. Both possibilities are there. So may or may not be regular. May or may not be regular. Example very simple. A plus B whole star is regular, but within that only you have A power n, B power n, but that is not regular. So A power n, B power n is a subset of the regular language, but it is not regular. Okay. So that is going to give you the subset of a regular need not be regular. Okay. Sometimes regular, sometimes not regular. Okay. Okay, I'll give some homework questions to practice. Okay, just try them and answer it if you can. Okay, if L1 is equal to A star, B star, C, and L2 is equal to A star, B power n, C power n. Okay, then what is L1 intersection L2? Then L1 intersection L2 is dash. Okay, options: A star, B star, C star, A star, B star, C, A star, BC, ABC. Okay, just choose whichever matches. If not matches, just mention in the comment. There's no option is correct. Okay, just cross check both which is a right option. Second one, if L is equal to A power n, B power n, then L star is dash. Okay, when the particular example is given, you should understand. So don't say clinic closure is not closed for DCFL, that's why it is not DCFL. Wrong. Clinic closure is not closed. That doesn't mean that the result is not DCFL. Sometimes DCFL, sometimes not DCFL. Remember that the clinic closure of DCFL may or may not be DCFL. For this DCFL, you may get a DCFL. You may not. Just you need to understand. Okay. So don't answer blindly not DCFL. That's wrong answer. Okay. So you know this. Now apply the clinic closure. Do you get a DCFL back? Okay. I'm just answering here regular. I'm also answering here DCFL. I'm answering here option. I'm giving the option CFL but not DCFL. So you need to identify which option, which answer is correct here. Which option is correct? Okay, not CFL. So find out carefully. Never apply the closure property now, because closure property is not closed. When the not closed is there, the result might be inside the domain, might be outside the domain. For a particular example, you should understand this example, what is the right answer. If L1 is regular, in fact I did not discuss this, but you should understand, L2 is a context-free language, then what is L1 intersection L2? Regular. I want always what is the right answer. Always I need you to answer. Not regular. CFL. Not CFL. Here only one answer is correct, so choose accordingly. Let's say L1 is regular, L2 is a DCFL, and L3 is a CFL. Okay, these three are given to you, and what you have to find is, using this, find L1 intersection L2 intersection L3 is dash. First option regular, second option DCFL, third option CFL, and fourth option is not CFL. Let's say we will answer this question. Okay, this concept is very important. You cannot just look at an answer that's wrong, right? Don't look at Venn diagrams. Venn diagrams are something different. Now the last one, which of the following is closed for CFLs but not closed for domain of DCFLs? Okay, something which is closed for CFLs but not closed for DCFLs. Let's see. Complement, is it really closed for CFLs? Not closed for DCFLs? Check. Union, is it closed for CFLs but not closed for DCFL? Check. And intersection, is it really closed for CFLs? And prefix. Okay, so only one answer is right here, so choose accordingly. The question is, which of the following is closed for CFLs but that operation should not be closed for DCFLs? So what is that operation name? Which of the following operation? I'm talking about operation. Okay, yeah. Thank you so much for watching this video, and see you in the next session. Bye bye, take care.